So I will just start where I left. I had to leave it because my phone was not completely charged. But anyway, let's continue with this. So we were doing, I think, which question? I think we were doing this question, this ninth one, and we had derived this equation. Okay, so I will just return that once again. Fine. So where I went wrong after deriving this was that I started to actually kind of make sense from this equation, but I could not make sense because I was sending this over there and then sending it over there and just doing cross multiplication and making it look even worse. But I thought for it for a while, and then I discovered this. So if I divide this whole equation by AC once again, then I can write it as a plus c upon AC whole squared is equals to 4 upon, well, b squared into AC. Okay, but now I'm going to write it in this bracket. So AB plus BC minus AC upon b squared AC. Okay, well, that makes it so AB upon b squared AC. Well, I can factor out 1 by b from this, and then the remaining would be ABC in the denominator. So AB upon ABC, that's going to be 1 upon C. Then over here it's going to be 1 upon A, and then 1 minus B. Fine. And over here it's going to be 1 upon A plus 1 upon C. So now what I'm going to do is that I'm going to call 1 upon A plus 1 upon C as M, and 1 upon B, instead of saying 1 upon B, let's say 2 upon B as N. Okay, and then let's rewrite this equation now. Okay, so this equation then it can be written as this is M squared is equals to, when you completely expand this, you get 4 upon B into 1 upon C plus 1 upon A. That's going to be N into 4 upon B, but 4 upon B is 2N, so 2mn, and then minus 4 upon B squared, but that is exactly N squared, so minus N squared. That gives me M squared minus 2mn plus N squared is equals to 0. In other words, M minus N whole squared is equals to 0. So N should be equal to N, which means that 1 by A plus 1 by C is equal to 2 upon B, which means that 1 by A, 1 by B, and 1 by C are in an arithmetic progression, which means that A, B, and C are in a harmonic progression. Okay, let's go to the next question. If the first two terms of an HP are 2 by 5 and 12 by 23, then the largest positive term of the progression is, okay, just a repetition of one of its kind. Fine. So when you take the corresponding AP of this harmonic progression, the first term of that AP will be 5 by 2, the second term will be 23 upon 12, and then it will keep on going with some common difference. Here the common difference is going to be 23 upon 12 minus 5 by 2, which is 23 minus 6 is like minus 30, and then upon 12 this is minus 7 by 12. Okay, fine. We have to find the largest positive term of the progression of the harmonic progression. So in other words, we have to find the smallest positive term of this progression, of this arithmetic progression, and then we have to flip that to get the largest positive term of that harmonic progression. Okay, fine. So 23 by 12, and then the next term is going to be I think 16 upon 12. Then the next term is going to be 9 by 12, and then the next term is going to be 2 by 12. Fine. So which means that 2 by 12 is that's going to be the smallest positive term of this arithmetic progression. So when you flip it over, you get 12 by 2, which is 6, as the largest positive term of this progression. Fine. This was easy. So is 6. Fine. If A, B, C are in AP, and B minus A, C minus B, and A are in GP, then A is to B is to C is. Okay, fine. So these things are in a GP, which means that C minus B squared is equals to A into B minus A. And by the way, A, B, C are in a AP. Fine. Which means that B minus A is equal to C minus B. And what we can do is like call this D maybe. Fine. So here you will get D squared is equals to A times D, which means that A is equal to D, which can be written as B minus A, right? That gives me B is equals to 2A. So that means the ABC are going to be like this: A, 2B, and these are supposed to be in AP. So sorry, A, 2A, and then 3A. So A is to B is to C is 1 is to 2 is to 3. Okay, let's just check if this is really a GP then. So B minus A, that will be A. Okay, that will be A. And then C minus B will be A and A. Oh, yes, this is completely a GP with the common ratio being 1. Fine. Let's go to the next question. If A, B, C are in harmonic progression, then the value of what is this thing? 1 plus B, 1 upon B plus 1 upon C minus 1 upon A into 1 upon C plus 1 upon A minus, oh, okay. So A, B, C are in harmonic progression, which means that 1 upon A, 1 upon B, and 1 upon C are in arithmetic progression. Okay, so let's say that the common difference of this arithmetic progression is D, which means that I can write this 1 upon C minus, okay, let's write this 1 upon B minus 1 upon A as D. So that will give me 1 upon C plus D, I think. Yeah, that should be correct. Okay, fine. Yeah, that's correct. And then over here, similarly, we can write 1 upon C minus 1 upon B as D. So this will be 1 upon A plus D. Okay. Then the value of this thing is, okay, this is weird. Over here, one of them is completely gone. You can either bring this in B and C or in A and C. Okay, I think I'm going to bring it in A and C. So D is 1 minus C minus 1 upon A upon 2. Just hope this works. So this is going to be 1 upon C plus, yeah, so 1 upon C minus 1 upon A upon 2 into 1 upon A plus, oh, this can be very weird, 1 upon C plus T. I don't think it's a good thing to have. Okay, 1 upon C plus T, what can we write it as? Well, 1 upon C can be written as 1 upon B plus D, but then plus 2D. That does not make any sense. We don't have anything for it. Yeah, so that's weird. Okay, fine. Let's just look at this. Let's see what happens. Maybe something will turn out pretty nice. Okay, so you have 1 upon A. And these are in harmonic progression. This is completely correct. Yes, fine. Let's just do this. 1 upon A plus D is 1 upon C minus 1 upon A divided by 2. Let's see what that turns out to be. So let's multiply by 2, or there's like 1 by 4 something. So it's going to be 3 upon C minus 1 upon A upon 2 into, well, you have 1 upon A plus 1 upon C upon 2. I don't know where we're going with this. It doesn't look like it's going to work very well. Fine, so that's not what we were looking for, right? It's going to be more like 3A minus C into A plus C upon like AC squared, so 4A squared C squared, something like that. And that's not what we were looking for. Okay, yeah, because it's in C squared and AC. there are no constants over there, which means that, okay, what about the c squared termed? Yeah, this is completely not correct. That's not how it should have gone. Fine, which means that we are not supposed to be uh, making this into c and a. Let's convert this into well, maybe this one, right? Let's convert this into b and c. Hopefully that will work. So I can write this as, but the d can be written as 1 upon c plus 1 upon c minus 1 upon b, okay, plus, well, 1 upon a plus d, that's just going to be 1 upon b. That was easy. So this gives me 2 upon c minus 1 upon b into 1 upon b. That's going to be 2b minus c upon bc, but then there's this thing, so b squared c. Let's see, so this can be written as 2 upon bc minus 1 upon b squared minus 1 upon b squared. I'm not pretty sure if this works like that. So the difference, yeah, that's not what we were looking for, huh? So 2 upon bc, it should have been 1 plus 1 upon b squared. So maybe we are not supposed to do this in b and c. Fine, so let's just do this in b and a. Hopefully that will work. Okay, if it doesn't work, I will have to start it over again, which won't be fun. I just hope we are going correct on this one. Okay, let's convert this into b and a. Yes, so 1 by c plus, what can we write 1 by c? We can write 1 by c as I guess 1 by b plus d, and then you will have 2d over there, okay, 2 times of the difference, which is 1 by b minus 1 by a, and then plus 1 by a plus, sorry, this is supposed to be into 1 by a plus d is just 1 by b, no problem. So this will turn out to be, let's see, so 3 upon b minus 2 upon, I think we are going correct on this one. Okay, let's just erase this. So this will become 3a minus 2b upon ab squared, which is 3 upon b squared minus 2 upon ab. Oh yes, this was correct. I don't know why it came at last, but whatever, this was correct. Let's go to the next question. If a, b, c are in harmonic progression, then which of the following is true? 1 upon b minus a plus 1 upon b minus a equals to 1 upon b. Okay, this is obviously not true. This is creepy. Okay, b plus a upon b minus a equals plus b plus c upon, oh god, let's just look at every option first. So let's look at this option first. So it's going to be b upon a upon b minus a, and then I'm going to send it over there. So 1 minus of b plus c upon b minus c, that is b minus c minus b minus c upon b minus c. So this cancels, and then you have minus 2c over there. I'm going to write as 2c upon c minus b. Okay, what can we do with this thing? Maybe you can use componendo dividendo on this thing. Well, yeah, most likely that will work. So yeah, let's just do that. So let's add these two first. So that's going to give me 2b, and then subtract these two, subtract the denominator from the numerator. That will give me 2a. Let's add these two first. 3c minus b. Oh, that's not what I was looking for. And then c plus b. Okay, I don't think it's matching up pretty well. Yeah, it's completely not what we were looking for. Equals to 3ac minus, oh god, minus, well, ab. Okay, fine. Nope, that's not what we were looking for. That's not what we're looking for. Okay, let's go to the next option. which is okay, this is obviously not correct, so let's go to this option then. This should be correct, or otherwise you will have to choose none of these. So 1 upon b minus a is equals to 1 upon b minus of 1 upon b minus c. That is going to be b minus c minus b upon b into b minus c. That can be okay. So b into b minus c. This is going to be minus c over there, so c upon b into c minus b. Okay, so that gives me b upon b minus a is equals to c upon c minus b. Fine. uh, let's use component dividend on this thing, and no, I won't do that. So let's multiply it out. So that can give me bc minus b squared is equals to bc minus ac. Huh. Oh god, this means these are in geometric progression. Oh shit. Oh, this is not working very well. This option is obviously not correct, which means that this would have been correct, but then it didn't turn out too well. Well, let's just do this once again and see if we get anything out of it. I know, just do this once again. So let's cross multiply. So b squared plus ab. I don't think cross multiplying will help. Oh shit, why is this so damn hard? Okay, I think I got it. I think I know the whole process now. So what I'm going to do is that I'm going to divide this numerator and this denominator by ab. So that will give me 1 upon small a, okay, plus 1 upon small b upon 1 upon small a minus 1 upon small b. And then similarly I'm going to divide this by bc, so that will give me 1 upon small b plus 1 upon small c upon 1 upon small c minus 1 upon small b. That should be equal to 1. Now I'm going to call this as capital A plus capital B. That makes it look easier, plus capital B plus capital C upon capital C minus capital B. Okay, that is equal to 1. Here's the thing, we know that capital A, capital B and capital C are in an AP, which means that well, look at this, A minus C, that is 2 times the difference, and then this is 1 times the difference. Okay, maybe that's not what we were looking for. Let's see, let's just send it on the right hand side and simplify it. A plus b upon a minus c is equals to 1 minus of b plus c upon c minus b. Okay, it is going to be c minus b minus of b. Yeah, this is working somehow. Okay, upon c minus b, obviously. So these cancel. Oh sorry, not these cancel, and then over here you have minus 2b, which I can write as 2b upon b minus c. Okay, fine. I think this is working. This is working somehow. All right. So a upon b upon a minus c equals to 2b upon. Let's see what we get. Just cross multiply that out. So that will give me b squared plus ab minus ac minus bc is equals to 2 times of ab minus 2bc. Oh, that's nice. So one of them gets cancelled, and then one of them gets cancelled. So in effect you have b squared minus ac. Hey, did we get ac? Yes, we did get that. Okay, fine. B squared minus AC, well, we should not have. Okay, yeah, that's correct. Okay, fine. B squared minus AC is equal to AB minus BC. Okay, that's weird. There's nothing common over there. I don't know why is this not working. Okay, let's just do it once again. I really hate it when it doesn't work in 2 or 3 tries. maybe I'm just making some mistake once more. So c minus b, and then minus b, so this becomes minus 2b. So 2b upon, you will have b minus c. Fine. A, B, C are in our HP, so capital A, capital B, capital C is an AP. So maybe we can write 2. Oh, okay, wait. Why is this A plus C over there? Isn't it supposed to be something else? Yes, it is. Oh shit, I think I got it. So this is A plus B, and then this is A. Oh shit. Oh, here's where I went wrong. This is supposed to be A minus B. Yes, that's more like it. Fine. So hopefully that will give me something nice. Okay. So yeah, just cross multiply. So that will give me AB plus, well, B squared minus AC minus BC is equals to 2AB minus 2B squared. Okay, minus 2B squared. That is something which is not good. Oh, come on. Why is it like that? Is this even supposed to be like that? So B minus C. I'm getting tired with this thing. Fine. Let's see what we get. So one of them gets cancelled. Alright, you have 3b squared is equals to, well, AB plus BC plus AC. I think this might work. This might work actually. Oh yes, this can actually work. Let's see what we get. So that gives me 3b squared is equals to, let's factor out a b from these two, so that will give me a plus c, but a plus c is 2b, so this will become 2b squared plus ac. No, that's not working. That will give me like b squared equals to ac. So this only works if, oh come on, if b squared equals to ac, which means that ABC should be in a GP and arithmetic progression at the same time, which only happens when they are like equal. So no, it does not work like that. Fine, which means that none of these should be the correct answer. That is weird. Fine, the integers 2, a, b, c and 160 are such that the first three terms are in AP, while the last three terms are in GP. If the common ratio of the GP and the common difference of the AP are equal, then the value of A plus B plus C is, okay, so the first three terms are in AP, which means that 2 times of A equals to 2 plus B, and the next three terms are in a GP. Oh, and also the common difference and common ratio are same. Okay, so the common difference is going to be A minus 2, which is also B minus A. Okay, and the common difference, sorry, the common ratio, that's going to be C upon B, which is also 160 upon C. So this ratio is like equal to this difference. What can we say from that? Okay, so you got something in A and B, and this involves C, which is not good. Oh, here's the thing. So the ratio squared, that's going to be 160 upon C, obviously. So what if we like square the difference? Sorry, 160 upon B. So maybe we can just square the difference and then like square this term. Maybe that will give me something. Oh yes, that can work. That can work pretty nice. So B equals to 2a minus 2. We already know that from this equation. And then when we square this, you basically get a minus 2 whole squared or b minus a whole squared. Both of them basically work. Just going to call this as a minus 2 whole squared. Fine. Now I'm going to substitute this value of b over here. So that gives me 160 upon 2 into a minus 1. That is equals to a minus 2 whole squared. Oh wow, that is awesome. Oh wait, but that means like this is going to be something like a cubic. Oh shit, that's not what we wanted. Fine, I'm not sure we are ready to solve a cubic yet. We have to look at some other way then. So which of these equations should we equate first to get the answer easily? Sure, you can equate c square equals to 160b. That's one of the ways. And then you can also equate these equations somehow. Okay, I don't know, this is taking forever. So the difference is basically the same. Oh shit, that's how it's supposed to be. Let's call the difference as x. Okay. Oh, now I got it. Okay, so this a is going to be 2 plus x. Obviously this thing is a, and then b is going to be this plus x once again, so 2 plus 2x, obvious. But now c is c is going to be x times of this thing, which means it's going to be 2x plus plus what's this thing, plus 2x squared. Fine. And then when you multiply this by x once again, so you get 2x squared. Oh shit, it's still a cubic. Anyway, we have to solve this now. Is equals to 160. Okay, I know that's not what we were looking for, but fine, maybe we can try solving a cubic. X cubed plus x squared is equals to, what is this thing? This thing is 160 upon 2 is like 80. Fine, just think of it. Is there like anything which you can do? X cubed plus x squared minus 80 equals to 0. We have to solve this cubic, otherwise we won't get the answer. Okay, let's see, are there any factors or like any obvious solutions? Let's try x equals to 4 maybe, so like will be like 64. Oh okay, that's working. Let's set x equals to 4, so this will become 64 plus 16. Oh shit, this does work. Okay, so x equals to 4 is the solution. Wow, that was fast. Like for for somebody like me, this was really fast. Fine, so x equals to 4 is the solution of this thing. So we can divide this by x minus 4. You got x cubed plus x squared minus 80. Let's say you have x squared, it's going to be x cubed minus 4x squared. Just subtract this, so that gives me 5x squared minus 80. So we need plus 5x, that gives me 5x squared, and then minus 20x, subtract that out, that gives me 20x minus 80. So we need plus 20 for this thing. Okay, that was nice. Oh shit. So x squared, so x equals to 4 or x equals to 4 or x squared plus 5x plus 20 is equals to 0. Let's see, does this have any kind of factors? So 20 can be written as 10 into 2 or 4 into 5. Wait a second. Oh shit, let's just check the discriminant of this thing. It's going to be 25 minus 4 times of this thing is 80. Oh, that's negative, which means that this has no real solutions. So x equals to 4 is the only thing which can happen. So x equals to 4, so you have 2, then you have 6, and then you have plus 4 is going to be 10. Then you multiply by 4, so that gives me 40, and then you multiply this by 4 once again, so that gives me 160. That was nice. So what do we have to find? The value of a plus b plus c, which is like the sum of these three terms. That's going to be 56. Easy. Okay, let's go to the next question. If a by b, b by c, and c by a are in harmonic progression, okay, then a squared b, okay, these are in harmonic progression. This might be multiple choice, who knows. So what can we do? We can just multiply by a b, c, and it will still be a harmonic progression, which means that a squared c and then b squared a and c squared b, this should be in a harmonic progression. Let us see this. This is not what we wanted. B squared A should be included, but wow, this is obviously not something which you might want in a geometric progression. Well, that is weird. So this harmonic progression is not present. It's saying A squared B, okay, B squared C, and C squared A. That is in a harmonic progression. Not sure how he got that. Okay, then you should multiply by B by C to get this thing. Are in a harmonic progression. So you have to multiply by B by C over here, and then C by A over here. These are in harmonic progression, obviously, but nope, it does not work like that. What I think is the first one might be correct, so let's just, and there can be more of them which are correct, but who cares? That should be easy enough to prove. So let's do this thing. So we know that B upon A, C upon B, and A upon C, this should be in an arithmetic progression. So let's multiply this by ABC. So that will give me B squared C, C squared A, and A squared B. That is in a arithmetic progression, or in other words, if you reverse this, you get A squared B, C squared A, and B squared C in an arithmetic progression. Yes, that's exactly what it says. So let's go to the next question. So if A, B, C are in a geometric progression, then log base A of x, log base B of x, and log base C of x are. Yeah, so A, B, C are in geometric progression, which means that log base x of A, log base x of B, and log base x of C. This is AP is arithmetic progression, which means that when you reverse this, when you take the reciprocal of that, so 1 upon log base x of A, 1 upon log, and 1 upon this thing, this will be a harmonic progression. But now I can use a property of log and say this is going to be log base A of x, log base B of x, and this log base C of x. That should be a harmonic progression. Fine. Go to the next question now. If first and 2n minus 1th term of an AP, GP, and HP be equal, wow, okay, and their nth terms are respectively A, B, and C. Okay, that is weird. Okay, so the first terms are equal, so let's say the first term is A for all of them. Then the 2n minus 1th term of an AP, GP, and HP are equal. Okay, wait, what happened? Why did the brightness go down? So the 2n minus 1th term of an AP, that's going to be A plus 2n into whatever the difference is for the AP, and then the 2n minus 1 and 2 minus 1 2n minus 1th term of a GP, that's going to be 8 times the ratio to the 2n power, and then for the HP, that is going to be okay, that is weird. So 1 upon A plus, oh wow, this is weird, plus what, plus the difference of like the harmonic progression. Fine, so 2n times the difference of harmonic progression. Okay, these are all equal, and the nth terms are respectively A, B, and C. Oh shit, A got used up in that as well. I cannot use it now. Fine, it's gonna use capital A for this so that I don't create any confusion. Capital A, capital A, and capital A. The nth terms are respectively A, B, and C. Fine. Two nth terms are equal. So you have, okay, so for the harmonic progression, the first term is capital A, which means that for the corresponding arithmetic progression, the first term is 1 by capital A. The difference, let's say, is dh, so plus 2n times dh. That's going to be the reciprocal of the 2n minus 1th term. Okay, that should be Okay, so the reciprocal of that thing, that will be the 2n minus 1. uh, Wait, what? 2n minus 1? Shit, it's supposed to be 2n minus 2 then, into dh. Okay, that is going to be the 2n minus 1th term of that harmonic progression. That should be equal to, oh come on, this is not cool. Let's just use the other fact first, that the nth terms are a, b and c. Okay, that might give us something. So you have a times okay, so a plus 2n minus 2, so sorry, a plus n minus 1 times the difference, that is a, I mean small a, and then a times the ratio to the n minus 1th power, that's also okay, that's b. Fine. And we are given that okay, so the 2n minus 1th term of ap, those are going to be equal. Okay, fine, we can try to add them up. That will give me something. Okay, so when you add n minus 1 d to it once again, that basically gives me a plus 2n minus 2 into d. That is going to be a small a plus n minus 1 into d, obviously. And then when you multiply this by r to the, okay, that's just becoming more and more gruesome. Oh come on, this is weird. So the first terms are equal, all that stuff is nice. Oh come on, fine. So, oh no, that's not what we should be looking for. Oh, this is pretty weird. Okay, so what do we know next? Okay, so this a is common, right? And let's say that that common term, that common last term, I mean 2n minus 1th term, that may be x. Okay, that can be x. So that will give me a plus 2n minus 2 into d is equals to x, which means that small a plus n minus 1 into d is equals to x. Or maybe just let that be, let's just use this like that, is equals to x. Fine. And then a times r to the 2n minus 2 is equals to x once again. Okay, so I think what I'm going to do is that I'm going to write d in terms of a and n everywhere, so that will help me a little. And then 1 upon a plus 2n minus 2 into the, say, the capital D, like, fine, that's equal to x. Okay, what can you do with that? Okay, so I'm going to write a and okay, I'm going to write d r and this capital D in terms of x and a and n, so hopefully that will give me something nice to use. Okay, the first terms are equal, you got all that stuff. Okay, let's just do this now. So the only different thing is like the difference in the ratio and this difference. Let's just use this. So it's going to be x minus a upon 2n minus 2. Okay, nice. Let's erase this. And then you have okay, so the ratio is x upon a raised to 1 upon 2n minus 2. Okay, that's one of the equations, this is one of the equations, and this can be a little tricky. So what can you do? You can have 1 upon x equals to 1 upon a plus 2n minus 2 into d, which means that d is, okay, just erase this thing, which means that the difference, that's going to be equal to 1 upon x minus 1 upon a upon 2n minus 2. Okay, these are the three equations which you could derive. Fine, and now we will be trying to make some relation between to have some relation between those a, b and c, the small a, b and c. I don't know if we will be able to make any relation, but let's try. Let's just give it a try. These are like three important equations. I don't know if these are like that important to solving the problem, but let's see what we get. Fine. So the next thing which we are given is the nth terms are respectively a, b and c, which means the nth term of that ap is going to be a plus n minus 1 into d. Okay, that is going to be a. Now I'm going to substitute this value of d over there, so that will give me a plus n minus 1 into this thing. This is like x minus a upon 2 equals to a. So small a is equals to so 2a is going to be x plus a upon 2. Fine, that's another important equation. And I think it's the n is going to get like cancelled away in all of the equations. Oh, why is this not getting selected? Okay, I think n is going to get cancelled in all of the equations. And what's this thing? Okay, fine. And you have the nth term of the gp as b, which means that capital A times r to the n minus 1, that should be equal to b. Okay, fine, that is equal to b, sorry, small b. Now I can substitute the value of r from this equation into this equation, so that will give me a times, okay, that will be something like x upon a to the half power is equals to b. That basically gives me b squared equals to a times of x. That's another relation. Just erase everything else. Okay, so that's a good thing to know. Fine. And then what other thing you have? You have the nth term of the harmonic progression, which is going to be 1 upon is yeah, that's going to be equal to 1 upon c, right? So 1 upon c is the nth term of the corresponding arithmetic progression. Fine, that's going to be 1 upon a plus n minus 1 into d. So that's like 1 upon c is equals to 1 upon a plus, well, what's d? D is this thing. Okay, fine, so that's going to be 1 upon x minus 1 upon a upon 2, which gives me 1 upon c is equals to, well, 2. This is going to be 1 upon a plus 1 upon x upon 2. Okay, so now we have written everything in terms of a and x completely. So that gives me like c is equal to, you have x plus a in the denominator, and then you have 2ax over here. So that gives me, what do we have to find? We have to find a relation. Fine, so c is equals to 2b squared, okay, upon a plus x is, so a plus x upon 2, that's going to be, so okay, a plus x is going to be 2a, which means it's going to be 2a over here. So that gives me 2a over there. This cancels completely, so b squared equals to ac. Then okay, so a plus c equals to b, a is equals to b equals to c. Here it should have been b squared equals to ac, but fine. None of these. Yes, then there's only one thing which can happen, none of these. Yeah, that should happen. Okay, fine, so it's maybe none of these. I don't know, that's it. Okay, what the heck. Fine, there is another possibility that a is equals to b equals to c, so maybe that can happen as well. Fine, I don't know, this is very tricky and we're going to need a lot of time to solve this, so better not waste more time on it, because now we just know the whole process. So if a, b, c are in harmonic progression such that a plus b plus c equals to 37, 1 by a plus 1 by b plus 1 by c is equals to 1 by 4. Okay, the smallest number is so these are in harmonic progression, which means that 2 by b is equals to 1 by a plus 1 by c, something like that. So let's say that 1 by a is capital A, 1 by b is capital B, and 1 by c is capital C. So you have capital A plus capital B plus capital C is equals to 1 by 4, which means that 3b is equals to 1 by 4, because capital A plus capital C is 2 times of capital B, which means that capital B is 1 by 12. Okay, at least we know one of the numbers, like the middle term is going to be 12. So what do you have from that? We have a plus 12 plus c equals to 37. Just paste this, like, now we know the middle term. It's like b equals to 12. Okay, fine. So a plus 12 plus c equals to 37, and 1 by a plus 1 by 12 plus 1 by c is equals to 1 by 4. Which means that 1 by a plus 1 by c is going to be 3 minus 1 is 2. So 2 upon 12 is 1 by 6. Over here you will have a plus c is equals to, well, what, 5 and then 2. Okay, cool. So you have two equations. Let us see what we can do with it. Now we need to find a and c somehow. Okay, so let's multiply this by ac. Nah. Okay, fine. So a plus c upon AC is equals to 1 by 6. Now we know that a plus c is 25, so this is going to be 25 upon AC equals to 1 by 6, which means that AC is equals to 6 into 25. Fine, which is, I think 5 into 6 is 13 into 5 is going to be 150. That's nice. Okay, so this is one of the equations which we got, and this is one of the equations which I will be using now. Okay, fine. So using these two equations we can find a and c. Let's multiply this by a, so that will give me a squared plus ac plus is equals to 25a. Fine, we know that ac is 150, so a squared minus 25a plus 150 is equals to 0. 150 can be written as 15 into 10, so this gives me a minus 10 into a minus 15 is equals to 0. So a equals to 10 or a equals to 15. If a equals to 10, then b is going to be equal to 15. Otherwise b is going to be equal to 10. Okay, yeah, that should work. So the smallest number is, so you have a equals, suppose like this works, then 10. You had, what was c then? I don't remember what was c. Yeah, I think I remember. It was 12. Yes, it was 12. And then you have 15, I think. Are these in harmonic progression? Well, we don't know. Let's see. So 1 upon 10. What's the LCM? This is, okay, 1 upon 10, 1 upon 12, and 1 upon 15. Are these in harmonic progression? So let's multiply this by, say, 3. That will give me 30. So 3 upon 30. This can be, we just not do that. Was this really 1 upon 12? I think we are going wrong on that. Fine. So now we know this result, that one of them is 10 and one of them is 5. How much back can we go with this? We can't go any further. Fine, just erase this. So we know one of them is 10 and one of them is 15. What was the middle term basically? So the middle term was, yes, it was 12. I know. So 10, 12 and 15. These are the three numbers. Okay. Are these in harmonic progression? Let's just check that. So 1 upon 15 minus 1 upon 12. What's that going to be? That's going to be 2 upon 30 minus what's this, 5 upon 60, I guess. So it's written as 4 upon 60 as well. Fine, so that is going to be minus 1 upon 60. Cool. And then 1 upon 12 minus 1 upon 10, what's that going to be? So just multiply by 5, that will give me 5 upon 60 minus 6 upon 60, which is minus 1 upon 60. So yes, these are in harmonic progression. So the smallest of them is 10. Easy. Yep. So if x is less than minus 1 and x mod x plus 1 and mod x minus 1 are in AP, fine, then the sum of the first 20 terms of the AP is, okay, so x mod x plus 1 and mod x minus 1 are in the AP. X is less than minus 1. Oh wait, x is less than minus 1, which means that all of them are negative. Okay, so mod x plus 1 can be written as minus of x plus 1. Okay, fine, that should work. So here's the deal. Now that x is less than minus 1, okay, so you will have x plus 1 is less than 0, which means that mod of x plus 1 is equal to minus of x plus 1. Okay, and then x minus 1, well, that's already negative because this is negative, which means that x minus 1 is the mod of x minus 1 is also negative of x minus 1. So what that basically means is that x, the negative of x plus 1 is minus x minus 1, negative of this thing is minus x plus 1. This is an AP, which means that minus 2x minus 2 is equal to the sum of these two. Is going to be, well, that's gone, so 1, which means that minus 2x is equals to 3. So x equals to minus 3 by 2. Easy. Fine, then the sum of the first 20 terms of the AP. Oh, okay, the first 20 terms, but what is the first term? I think x is the first term, maybe, whatever. So x plus 1 is going to be minus half, so x plus, the mod of x plus 1 is going to be positive half. So over here you have to go up by 2. Okay, so the common difference is 2. The first term is minus 3 by 2. So the common difference is 2. The first term is minus 3 by 2. We have to find the sum of the first 20 terms of the AP. So it's going to be 20 upon 2 is going to be 10 into 2 times of this thing is going to be minus 3, minus that guy is minus 5, plus 20 into the difference, fine, which is going to be 40. This is going to be 35, I guess. So 350. Yes, that is correct. So to the next question. So if A1, A2 all the way to, why is this over here? Okay, if A1, A2 till A10 are in AP, H1, H2 till H10 are in HP, and A1 is equals to H1 equals to 2, and A10 equals to H3 equals to 3. Then A4 and H7, the product of that, what is that? So the first term is 2 in both of them, okay, and A10 equals to H10 is equals to 3. Fine, so A10 is going to be the first term, which is 2 plus 9 into the difference for AP, and then the H10 is like going to be 1 upon, the reciprocal of the first term is 1 by 2 plus plus like 9 into the difference for the difference for HP, right? So these are equal to 3. Okay, this is equal to 3 and this is also equal to 3. We can find dA and dH from this. Okay, that's nice. So that means that what dA is equals to minus, sorry, not minus, positive, fine, 1 by 9, correct, and then 1 by 3 equals to 1 by 2 plus 9 dH. So 1 by 3 minus 1 by 2, that is minus 1 by 6 is equals to 9 dH. So dH is equals to minus 1 by 54. Okay, those two equations should work. And now we have to find what do we have to find? A4 into H7. So A4, that is going to be, the first term is 2 plus 3 times of this difference is going to be plus 1/3. That should be, guess what, 6 plus 1 is like 7, 7/3. Okay, and then H10, this is supposed to be equal to H7. Okay, that is going to be 1 upon, the reciprocal of the first term is 1/2 plus 6 times of this thing, so it's going to be minus 1 upon 9. So what is that? 9 minus 2 is 7, something upon 7. And then you have 18 over here. Fine, so you will have 18 upon 7 into 7 upon 3. That gives me 6. Yes, that is correct. To the next question. If A, X, Y, and Z and B, okay, these 5 are in HP, if 1 by X plus 1 by Y plus 1 by Z is equals to 5 upon 3, then 1 by A plus 1 by B is, that is easy. Okay, here's the deal. We know that 1 by A plus 1 by B, well, first of all, AX, Y, Z and B are in HP, which means that 1 by X, 1 by A, 1 by X, 1 by Y and 1 by Z and 1 by B, these are in arithmetic progression, which means that 1 by A plus 1 by B, that is going to be 2 times of this middle term, so 2 upon Y. But 1 by X plus 1 by Z, that is also 2 upon Y, so you have 2 upon Y plus 1 upon Y is equal to 5 upon 3, so 3 upon Y is equals to 5 upon 3, so 2 upon Y is going to be 10 upon 9. Yes, that works pretty well. This was easy, just leave it. Okay, if A, B, C, A are in harmonic progression, then B plus A upon B minus A plus B plus C upon B minus C is equals to, I think we did a similar question already, maybe that is equals to 1. Okay, these are in harmonic progression. Fine, here's what I'm going to do. I'm going to write it as 1 upon A, 1 upon B and 1 upon C are in arithmetic progression, obviously. So now I'm going to divide this by AB, so that gives me 1 upon A plus 1 upon B upon 1 upon A minus 1 upon B plus what's this thing, suppose the difference is D. Fine, and then 1 upon C plus 1 upon B upon 1 upon C minus 1 upon B. Let's take a difference common from it. It's 1 upon D, right? This is the common difference, this is the common difference. We have this thing 1 upon A plus 1 upon B and then 1 upon C plus 1 upon B. This is going to be 2 upon B plus 1 upon A plus 1 upon C, but 1 upon A plus 1 upon C, that is going to be 2 upon B as well, so you will have 4 upon B over here. Okay, so 4 upon B into the difference. Well, what should we do with this? Okay, fine, that's weird. 4 upon B and then you have this difference thing. I know it's supposed to be equal to 1, but this is just weird. What do we do with this difference? These are in harmonic progression. What can we do with this? I don't know, this is not working very well. 1 upon A plus 1 upon B, yeah, that difference is common. Fine, just have this much over there. Okay, 1 upon A plus 1 upon C, that's going to give me 2 upon B. This is also 2 upon B, so this is 4 upon B. That is completely correct. So what's the deal with this, man? Something is off. I pretty much know this is going to be 1 because we did a similar kind of question already, but this is not working. I'm sure I'm missing something over here. Oh yes, obviously I'm missing something over here. How could I do that? So 1 upon a minus 1 upon b is not the difference but negative of the difference, which means when you take the difference common, you have to make this negative. So minus 1 upon a minus 1 upon b, plus 1 upon c plus 1 upon b. This cancels. 1 upon c minus 1 upon a, that should be 2 times the difference, and then you have 1 upon this. Oh, that is equal to 2. How can that be? We did a similar question, right? But I think that's what we are getting, so let's just go with it. Fine. That's weird. Fine, this is supposed to be equal to 2. But in the previous question, just did something else, I think. Oh yes, this was not correct. Yeah, that's why we chose none of these, because this is supposed to be 2. Yeah, now I got it. Okay, so the ratio between the GMs of the roots of the, I think this is the last question. Fine. So if the ratio between the GMs of the roots of the quadratic equations ax squared plus bx plus c equals to 0 and lx squared plus mx plus n equals to 0 is, wait, what? Oh, okay, I got it. So the ratio between the GMs of the roots of the quadratic equation, which is going to be square root of the roots of this thing, which is like alpha beta, say this has roots alpha and beta, upon the square root of alpha. So I got, okay, so gamma into delta. Fine. So suppose gamma and delta are the roots of this equation, alpha beta are the roots of this equation, then the ratio between the GMs, that's given by this quantity, right? This is the GM of the roots of the first equation. This is GM of the roots of the second equation. Now I'm going to use that alpha beta, that is just c upon a upon the square root of n upon l. That's going to be the square root of c into l upon a into n. Yes, correct. Plus minus. Well, yeah, obviously, because it might be possible that a and c, these are negative. In that case, you will have to have, sorry, it might be possible that alpha and beta are negative. So in that case, the geometric mean should be like negative square root of alpha beta, but we don't know if they are positive or negative, so just put a plus minus over here. Similarly, you can put a plus minus over here, so that will give me plus minus of cl upon an. That makes sense. Okay, let's go to the next question. If g be the geometric mean of x and y, then 1 upon g squared minus x squared plus 1 upon g squared minus y squared is equal to, oh, so the g is the geometric mean of x and y, which means like g squared is equals to x into y. So you just have 1 upon, you can factor out x from this, that gives me y minus x over here, plus you can factor out a y from it. Alright, that gives me x minus y over here, and you can see that these two quantities are negative of each other, so that basically turns out to be 0. Wait, what? That's not 0. Something is not working. G squared minus x squared. G squared is obviously xy, so you should be having x into y minus x over here, and then, oh, obviously, oh, that is not correct. Fine, so this is supposed to be 1 upon x into y minus x minus 1 upon y into y minus x, which can be written as 1 upon y minus x into 1 upon x minus 1 upon y, which is basically y minus x upon xy. Guess what? Something cancels. Fine. 1 upon xy. But 1 upon xy is basically 1 upon g squared. So B is the correct option. Fine. So that was it. And now my homework is complete. I will see you in the next video. Thanks for watching.